All right, well, we're starting factors and products in Math 10-3 10C Prep. So this is a 10C Prep unit, review of Math 8 and 9 algebra skills, and then looking into some of the concepts that you'll learn in Math 10C next semester. So first we have to review some of our polynomial knowledge. So if you take a look, it asks you, or it gives you a definition. A formula is a general rule for calculating something. So give some examples of formula that you know. So think about different ones that you might have used in science, in math, any type of formula. So I'm going to use the Pythagorean theorem and distance equals speed times time. Okay, so I've written out those formulas there. Next part says variable. Those are letters representing different values. So those are the variables in your formula that you use or in any type of relation, okay, where you come up with an equation that relates to variables or more than two. The word variable means that you can change the value of it, so it varies. So it says take one of the formula from question 1 and identify the variables. Indicate clearly what they represent. Okay, so I chose the second equation. D is the distance, speed is the time, S is speed, and T is time. So in order to calculate a distance, you need to know the speed that you are traveling, and you multiply it by the time. Okay, an algebraic expression is an expression involving variables. So 3x plus 5y is an algebraic expression. This next one is not an algebraic expression. It's all numbers, right? So it's just an arithmetic expression. You'd follow the order of operations to simplify it. So true or false, if the values are substituted into a formula, then it becomes an arithmetic expression. So that's true because all of the variables would be numbers. So then you would follow order of operations to evaluate it. Okay. Coefficient, numbers that are multiplied with variables. So these are numbers that are, usually they're shown in front of a variable, but it's understood to be multiplied. So for example, the height in meters of a ball thrown in the air is given by 80t minus 5t squared, where t is the time in seconds. In this expression, the coefficients are 80, so that's the number that's multiplied by t, and negative 5. So remember, you have to take the sign in front of the term, so to the left of the, in front of the variable. So to the left of t squared is negative 5. So list the coefficients in each of the following expressions. So just list them. So in front of the x squared is a 3. In front of the xy is a subtract 5, which means negative 5. And then positive 2, which we don't have to show the plus, it's positive 2. So you can just put a comma in between. Here in front of the a is negative 14. Then in front of the b, there isn't anything. But that's not 0. That's understood to be a 1. We just don't always show it. So that would be 1. And in front of the c, there isn't anything shown, so that would be negative 1. Okay. What's a monomial? So a monomial is a number or the product of a number with one or more variables where the exponents on the variables are natural numbers. So remember, naturals start at 1 and go up consecutively. If they're, you could say actually whole numbers for the exponents, because anything to the exponent anything to the exponent 0 is 1. So these would still be, this here is still considered a monomial, even though there are no variables, because you could have an x to the 0, right? That's really what that represents. And then when you simplify, that's negative 15 times 1, which is negative 15. And so same with 250. Then here, we've got an x term, an a squared. These are all natural numbers, all of those. Now, what is not a monomial even though it's a single term, if you take a look at this, remember when we learned back to negative exponents, that's the same as 1 over n cubed. Okay, and so monomial technically does not have variables in the denominator. Same thing here. Remember we learned about an exponent of 1/2. That's the same. This is equal to -8 times the square root of p. Okay, so even though it's one term, technically it's not a monomial. Okay, so a polynomial is basically a bunch of monomials put together. Okay, a monomial is a specific polynomial. So there's a monomial. Okay, or the sum of two or more. So this is still a monomial. And then this is 3 terms. Okay, this is 2 terms. And this is 4 terms. Those are all polynomials. Poly means many. I can't use a pen right now, so I'm using my mouse. I'm a little bit slow. Okay. So we have special names that can be used for polynomials. So terms, remember, are separated by adding and subtracting signs. So they're basically monomials within a polynomial. So expressions separated by a plus or minus sign. So examples are here n. So that's just one term because there is no plus or minus. Here this is 1 plus, so it's 2 terms. Here there's a minus and then a plus, so it's 3 terms. And we have some special names. So we've already talked about monomials, right? For a binomial, that would be this example here. So 2 terms. Think about how a bicycle has 2 wheels. So a binomial has 2 terms. And then 3 terms would be this. So same analogy, a bicycle has 2 wheels, tricycle has 3. So this is a trinomial. Sorry again for my slow writing here. Okay, and then there's no special words for 4 or more terms, so we just call them a polynomial, and we say how many terms there are there. So take a look. These questions, it says indicate if the following are monomials, binomials, trinomials, or 4 or more terms. So here there's no adding or subtracting, so that would be a monomial. I'm just going to abbreviate. B, there's 1, 2, 3, 4, because there's 3 adding, subtracting signs. So this is a poly with 4 terms. Okay, and then the next one, C is 2 terms, so that would be a binomial. Okay, over to D, that's 3 terms, so that would be a trinomial. Again, I'm just abbreviating because I don't have my proper pen. Then the next, there's no adding or subtracting, so that's a monomial. And then 2 terms here would be a binomial again. Okay. Then a constant term just means it's the degree is 0, so there's no variable. So a term in a polynomial that is only a number, no variables, is called a constant term. Okay, so the constant term here is 3. Okay, all the other terms have variables. Constant term each, and same thing, you have to look at the sign in front. So that would be -6. Here, this would be +12, so we don't have to show the plus. It's understood. And here, there isn't one. Okay, so there isn't one. Okay. Then, degree of a monomial. So, what the degree means is it's the sum of the exponents of the variables of the monomial. Okay, and really what it means is how many variables are multiplied together if you showed the monomial in the long form, okay, not using exponents. So here, if I were to show this expression without exponents, it would be 3a, b times b, and then times C, times C, times C. Okay, so how many variables are multiplied together? 6. 1 A, 2 B's, and 3 C's. Okay, so the degree is 6. So here, if we're looking at a monomial 17, it has no variable. It's just a number. So the degree of it is 0 because there's 0 variables, right? So its degree of a monomial is how many variables are multiplied together. So here there's just 1 variable. Here there's 2, A times B. Here there's no variables. Here there's S squared, which is 2 S's multiplied together. So degree is 2. And here 3 M's and 5 N's. So 8. Okay, so it's kind of like when you're multiplying powers with the same base, you add the exponents, but now they're not the same base. We are adding them because we're looking for how many variables are multiplied together. Then for polynomials, polynomials are made up of a bunch of monomials. So the definition for the degree of a polynomial is you have to look at all the degrees and whatever is the highest. It's kind of like the biggest value wins. So the degree of these terms here, if you take a look at this one, there's 2 x's and a y, so that's 3. I always show it above it. X times y, so there's 2. Just a y, there's 1, and 12 is 0. Okay, so there's 3, 2, 1, and 0 respectively. Highest degree is 3, so that's the winner. That's the degree of the polynomial. And normally we try to write polynomials in descending order of degree, so you can see that they're getting smaller as you go to the right. And that's what I've said here. So the term with the highest degree is written first, lowest is last, and then you fill in. So for each of these, determine its degree and express in descending order of degree. So this has no variable, so 0. A times B is 2, degree 2. A squared times B is degree 3. And just B is degree 1. So highest one wins. Okay, and then descending order of degree. So we have to put that highest degree term first. So 2 A squared B. Then the next highest is degree 2, so that's minus, remember you keep the sign in front, minus 7AB. Then degree 1 would be minus B. And then degree 0 is plus 4. Okay, next one has degree 1, degree 3, and degree 0. So 3 wins again. And it has to go first. So sign in front is negative, so negative t cubed plus 14t minus 2. Okay, and so some words that you will use, you need to get used to using. If it's a degree 1 expression or equation of a relation, then we call that linear. If it's degree 2, we call it quadratic. Degree 3 is cubic. Degree 4 is quartic. Degree 5 is quintic. And really, this is what we keep to. Often we say degree 4, degree 5, so that students don't get mixed up. But these 3 you do need to know. Grade 10, so 10C, you'll be learning about linear functions. Then in Math 20-1 or 2, you'll be doing quadratics. And then cubics and other polynomial functions, all the rest of these, in Math 30. Okay, so that's vocabulary.